This video will review three measures of central tendency: the mean, the median, and the mode. But first, what is central tendency and why is it important? Measures of central tendency are calculated in order to make large sets of data easier to summarize and understand. By calculating a value that can represent the typical score in a data set, we are making the data easier for people to process. Measures of central tendency that can help us identify an average, a centralized, or a repeated number, otherwise known as the mean, median, and mode, can help us conceptualize a large chunk of data in a very short period of time. Central tendency is useful because it simplifies the data. For example, if we know that the mean for a recent test was a 70% and you earned an 85%, then you know that you performed well above average. If we know the median for the test was a 75%, then you know for sure you performed in the top 50% of the class. Measures of central tendency not only help us understand and make meaning of the data, but also help us predict data. If we know the mean, median, and mode are the same or close to one another, we can predict that the scores are going to cluster around the mean and fall symmetrically on both sides of the mean. If we know the median and mode are higher than the mean, then we can predict that scores are going to cluster to the right, higher than the mean. If we know the median and mode are lower than the mean, we can predict that scores are going to cluster to the left, lower than the mean. The mean of a set of data tells us the number the rest of the data set is spread out around. It's what most people think about when they think about average. To calculate the mean, you add up the sum of all of the values in the set of data and divide by the total number of cases. As you can see on the screen, the statistical notation for that varies depending on whether you're calculating the mean for a sample or for a population. The population mean formula is mu equals the sum of all x values divided by the population sample size, symbolized by the capital letter N. The sample mean formula is x bar, or sometimes it's symbolized by an italicized M as well, equals the sum of all x values divided by the sample size, which is symbolized by a lowercase n. I want to take you through a quick example of how to calculate the mean of a sample. The sample formula is the sum of all x values divided by n, or the total number of scores. For our example, we're going to be calculating the 7-day average temperature this week in Death Valley in the United States. Looking at our data, you can see the predicted high for Monday is 113 degrees Fahrenheit. Tuesday is 111, Wednesday is 114, Thursday is 117, Friday is 120, Saturday is 120, and Sunday is 121. To calculate the mean of this set of data, we will want to add up all of those values together in our numerator. In our denominator, we will divide by the total number of values in our sample, which in this case is going to be 7. When we add up all of the values, we end up with 816 over 7. When we divide 816 by 7, we get 116.57142 and so forth. In APA format, we always round to the second decimal point, so our final answer is going to be the mean of the sample of data is 116.57 degrees Fahrenheit. The median is the middle value of a given set of data when the values in the data set are organized from smallest to largest. It separates the top half of the scores from the bottom half. Computing the median requires sorting the data, which isn't practical to do by hand if we're working with a large data set. However, it is easy to calculate in Excel or other statistical programs such as SPSS or JASP. In the example we're going to do together, we're going to use a small set of data. That way we can use the formula on the screen, n plus 1 divided by 2. Taking the median formula n plus 1 divided by 2, we are going to plug in our n size from our sample of Death Valley temperatures. We are interested in describing the temperature across 7 days, from Monday to Sunday, thus our sample size is going to be 7. Plugging that into our formula, we get 7 plus 1 divided by 2, which equals 4. This tells us that when our data is arranged from smallest to largest, the fourth value in the data set is our median value. Now that we know which value we're going to be looking for, we need to arrange our temperatures in order from smallest to largest. On the screen, you will see I arranged the temperature values in order from smallest to largest. According to our formula, the fourth value in the data set is our median or middle value. This means our median for this set of data is 117 degrees Fahrenheit. This is very close to our mean value of 116.57 degrees Fahrenheit. The mode of a set of data is simply the score that occurs the most. If there is one score that occurs the most, the distribution is called unimodal. In a unimodal distribution, you will see only one peak in the distribution of scores. A bimodal distribution has two data peaks, meaning it has two modes or frequent values. Looking at our set of temperatures from Death Valley, we can easily see there is only one value that occurs more than once in our data set, 120 degrees Fahrenheit. This is at least 3 degrees larger than the median and mean that we calculated for the same set of data. If we're working with a larger data set, it would be easy to ask the statistical program we're working with to calculate the mode for us. Now that we know 3 measures of central tendency, we need to discuss when we can use them. If we're working with nominal data, the only measure of central tendency that we can use is the mode. If we're working with ordinal level data, we can use either the mode or the median since ordinal level data is ranked to where we can find a midpoint. If we're working with interval or ratio level data, we can use any of the measures of central tendency, the mean, the median, or the mode. Let's discuss some advantages and disadvantages of each measure of central tendency to help you decide which to use. Take the mode. An advantage to using the mode is that it is not susceptible to outliers. A disadvantage is that it ignores most of the data and it only considers the score that occurs the most frequently. You want to report the mode if there is one score that dominates the data and when the data variables are nominal. The mode is, in fact, the only measure of central tendency that can be used with nominal level data. Next, let's look at the median. An advantage to the median is that it's less impacted by outliers or extreme scores than the mean. A disadvantage is that it doesn't report distance information since there are not necessarily fixed or equal distances between the values. It's a good idea to report the median as a measure of central tendency if you're working with data sets that have extreme values, if you have missing values, or if you're working with ordinal level data. Reporting the mean of a set of data gives a lot of information about that data set, including same different information, distance information, and direction information. Downsides to the mean are that it is impacted by outliers that can pull the mean up or down. Another disadvantage is that the mean cannot be used when the data is nominal or ordinal. If you're working with interval or ratio level data, you want to report the mean. However, if you have extreme scores in your data set, you'll want to supplement the mean with the median since it is less impacted by outliers. In summary, the mean, median, and mode are all measures of central tendency that can help us describe and understand a set of data. Deciding when to use each measure depends on the type of data you're working with and whether you have outliers in your data set. In general, however, it's always good practice to report all possible measures of central tendency since they each offer different information about a set of data by helping us identify an average, centralized, or repeated number.